Alright, so I'm going to try to explain these problems on this review packet. So again, if it goes too fast, just pause, rewind, watch it again, or ask your teacher. So number one, this is complete the similarity statement. So in this case, you have to match up the sides in order of size. So for example, like 15 is the smallest side in triangle CER, and so therefore you got to match it up with 10. So you can see how I kind of color-coded that. So looking at this problem, if I could look at 15 and 10, those are the corresponding sides. 18 corresponds to 12, 21 corresponds to 14. So in that case, 15 over 10 equals 18 over 12 equals 21 over 24. Those all are the same ratio. They're all 3 over 2. So when you set up the proportionality statement, you're going to take CER in that order, and it's like red and blue. So I'm going to go red and blue. I'm sorry. Yeah, sorry, CER goes red to purple. So I'm going to go red to purple, VAZ. That's how I did that one. Number two is a problem you probably just got to remember how to do. So in this case, they give you like the formula for what you're supposed to do to every point. So take every point and multiply the x and y coordinates by 0.4. So when you do that, like m is negative 10, 5. So negative 10 times 0.4, 5 times 0.4, negative 20 times 0.4, 15 times 0.4, and so on and so forth. So that's your answer there for that one. Number three is a problem that you haven't seen in a while. So the way you set this up is you take the sides, and you got four, a proportion has 4 parts, and you're going to set up the sides in a proportion. The way that we talked about this in class is you got to do it in a zigzag pattern. So if I do x plus 4 over 15, I got to come back and do 4 over x. Right? So that's not the only way to set it up. Like you could have set it up a lot of different ways. You could say x plus 4 over 4 equals 15 over x, and that way you're still going to get the same cross products. You're still going to get x plus 4 and x to be cross products, 4 and 15 to be cross products. So any way you do it should give you the same cross products, unless if you're zigzagging, that should be the way that it goes. Anyway, so back to this question. I'm going to take x plus 4 over 15 equals 4 over x. When I do that, I cross multiply, and I get 4 times 15 is 60. X plus 4 times x, you got to distribute the x to both terms, x squared and 4x. Be careful with that. A lot of people miss that step. And now you got a quadratic. I got to bring the 60 over, subtract it over. You get x squared plus 4x minus 60 equals 0. And now you factor that, so it multiplies to negative 60 but adds to 4. So in this case, you get 10 and negative 6. So when I get the answers, negative 10 is one of them, and positive 6 is my answer. Negative 10 is actually not a valid answer because negative 10 cannot be the length of a side, right? So therefore I got RT and then RS. So that's what I got there. Number 4, same kind of thing, got a zigzag pattern. So I set it up 10 over 15. I defined that this was 18. The whole side's 28. That would be 18. So 10 over 15 equals 18 over x plus 7. This one's not a quadratic. It's pretty easy to solve. You can see how to solve it. X is 20. Number 5, you got 2 problems here. So basically I kind of drew on top of this 15, but you want to find x, you could do this a couple ways, but I chose to use entire sides. So the first thing I did was I was like, okay, well this side is x plus 12 and this side is 20. So because I know that, now I could set up the problems using full sides. So 16 over 20 equals 12 over x plus 12. So that's what I set up here in the blue. So you can see so 16 over 20 equals 12 over x plus 12. That's what I set up here. Solve that equation, that proportion, you cross multiply, divide. Again, don't forget to distribute the 16 to the 12 and the x. That's going to be a problem again. So then I get 16x equals 48, x is 3. And the same goes for the other side. So I'm going to take 16 over 20 equals y over 15. So 16 over 20, y over 15. You set it up, you solve, you cross multiply, you get y is 12. That's a pretty good problem. Pretty heavy question based on what we did before. So 6, kind of the same thing. You got the proportionality statement. You know that, or not proportionality statement, the statement of similarity, which tells you which sides correspond, but LK corresponds to MN, so 18 over x over 18 equals 16 over x plus 12. So if I start x over 18, I got to come back to the small one and go 16 over x plus 12. You could have gone 18 over x, but then you got to go x plus 12 over 16. Either way, this should be your cross products. You get a quadratic. This is kind of a heavy one. You have 288 there. So you figure out what multiplies to negative 288, but adds to 12, 24, and 12. So negative 12, positive 24. You get x is 12 or negative 24. Clearly, I crossed that one off. So then you plug in the values. NM is 12. KJ is 12 plus 12. And then the similarity ratio, I just took the 2 sides. Now that I know this is 12, I said 18 over 12 is the similarity ratio. Reduce that. Take a 6 out of top, 6 out of bottom, you get 3 over 2. All right, bottom of that page, you got these problems. So you remember these ones, the geometric mean. So we talked about this. Some teachers are going to teach this differently, but the 8 is the geometric mean between 3 and 3 plus x. So the trick here, when we did this in class, we talked about like start at the big right angle, right? You slide down. From here, you can either go 3 or you can go the full distance, which is 3 plus x. So if I can erase some of that just so I can clarify what I'm doing. So I got the big right angles at the top. Slide down, you square it. Then you get 3. And then the whole thing 3 plus x. You don't want to do 3 and x because I'm not able to go just the distance of x from this point right here. So once again, I go 8 squared equals 3 times 3 plus x. Again, now you multiply, you distribute the 3. You get a decimal in this case. The next one, same concept, except in the big right angle, I'm sliding down the middle, so that's x squared. And then from here, so a big right angle here, slide down, I go either 4 or 6. So x squared equals 4 times 6. X squared equals 24 square root. You get a decimal again, a square root answer. All right, page 2. All right, page 2. You're talking about similarity rules. So there's 3 rules that make three things that make a triangle similar: angle, angle, side, or side, side. So we'll talk about each of those. Number 9, I got 2 angles congruent, 2 angles congruent. These 2 triangles are similar because of angle, angle similarity. That's the most common form of why triangles might be similar. Number 10 is probably the least common, but the only way I could do it is by angle or side, angle, side. So the way you got to do this is you got to check. I could zoom in a little bit here. You got to check that the sides are proportional, meaning I got to check that 3 over 4 is the same as 6 over 8, right? So 3 is to 4 as 6 is to 8. Is that true? Yes, that's true. Since these are vertical, I got a side, angle, side proportionality relationship. Therefore, those triangles are similar. The last case, it's kind of like the first problem. We got to match up the smallest sides and the biggest sides. So 4 matches with 6, 9 matches with 12, 6 matches with 9. 4 over 6 equals 6 over 9 equals 9 over 12. They all equal 2/3. Are the triangles similar? Yes, they are by side, side, side similarity. All right, number 12. So you're making a model. The model is 2 by 15, so I made that picture. The building is 510 feet wide, so I'm matching that up with the 15 because the model is 15 feet wide. So you're looking at the model, you're looking at the building, it's okay. The actual building, it's like how high, how tall is the actual building. So if it's 510 feet wide, the model's 15 feet wide. The building is x feet tall, the model is 2 feet tall. So you set up a simple proportion. 2 is to x, as 15 is to 510. Again, you got to go back and forth. It's a pretty simple formula. X equals 68, so the model is 2 feet tall. The actual building is 68 feet tall. Number 13, I'm just going to kind of let you look. These are the properties. I do want you to note, if there's a whole number on the side of a right triangle that's got isosceles right triangle, you got to make sure you cut that in half and add root 2. We could talk about how to do that. But more or less, this is just review. So there's 2 patterns you want to make sure you're aware of. So I'll just kind of draw these out. So 30, 60, 90 pattern. So you got the short leg x, the long leg x root 3, and the hypotenuse 2x. In that 45, 45, 90 pattern, you got these 2 sides are equal, so they're both x, and then the hypotenuse is x root 2. So that's basically all you're using for these. It's just a matter of what they give you and how to solve. All right, the next one's talk about Sohcahtoa. So number 14, they give us 64 is the angle, y is the opposite, x is the hypotenuse, 7 is the adjacent. So when we talk about Sohcahtoa, you're looking for the one you want to use to make the most sense. So in this case, I want to find y, and I have the adjacent. So I want to find the opposite. I have the adjacent. That's tan. Opposite and adjacent. So tan of 64 equals y over 7. You put it over 1. You cross multiply, solve. That's how we do it in our class. If your class does it differently, feel free. 64, again, now I have the adjacent. I want to find the hypotenuse. That's cosine. That's the only one that uses adjacent hypotenuse. And if you're like, what are you talking about? Well, you look at the second letters. The first letter is what it is. So that's sine, cos, tan. And then the next 2 letters tell you which sides you use and in what order. So in this case, I'm looking at 64, adjacent, hypotenuse. I know the adjacent. I want to find the hypotenuse. So cos of 64 equals adjacent over hypotenuse, 7 over x. Put it over 1, cross multiply. I did all the work kind of in my calculator, but you would put it over 1 and cross multiply and get your answer that way. Number 15, kind of the same, except instead of finding sides, you're finding angles. So in this case, I started by doing the Pythagorean theorem but to find AB, and got AB was 8.6. Okay, so I got a decimal for AB. You could get a radical if you wanted. Finding angle A, let's call it, angle A. So the tangent of A equals 5 over 7, right? So if I want to find this angle, I have to do what's called the inverse tan, right? When I find angles, I do inverse tan. So once I do that, I get A is 35.5 degrees. Make sure your calc is in degrees. So if you get a weird answer, your calculator is probably not in degrees. B, you can find two ways. Once you find A, if you're pretty sure about it, you can subtract from 90 to find this. Or I just did tan of B equals, tan of B now equals the opposite. So now it's changed, right? So the opposite over adjacent changes because the opposite to B is 7, adjacent is 5. So then I get 54.5. Page 3. Next one. All you do in Sohcahtoa, sine, cos, tan. You got to find the missing side first. So you do Pythagorean theorem. Found out that that side's 8. So then you do Sohcahtoa. So sine of C. Sine of C is opposite over hypotenuse. So that's 15 over 17. You can back it up a little bit and show you the other ones. The cosine of C is adjacent over hypotenuse. 8 over 15. And then tan of C is opposite over adjacent. 15 over 8. Alright, number 17. You got ladder leans against the building. It goes up. How far up the wall does the ladder reach? So this becomes a sine question again. The sine of 57 equals opposite over hypotenuse. X over 500, you get 419. 18. You're looking at finding the angle now. So once again, I got to do inverse tan. So in this case, this one kind of messed up. So let me correct this one. The actual trig function, if you could look at it, if you want to pause it and see if you figure it out. But I'm looking at x is opposite. That's hypotenuse. So this would be sine, and actually. So actually, I'm going to take sine of x equals 100 over 110. So my calculator I take and I do the inverse sine. So I'm going to do the inverse sine of 100 over 110. So in my calculator that looks like second sine, inverse sine of 100 over 110. And that doesn't give me 42.3. That actually gives me 65.4. So my bad on that. So the actual answer there, 65.4. So that the answer should be updated. We'll see if we can fix that. So anyway, moving on. This one I'm just going to, you can pause on this screen, but this is just something you got to study. You got to know these properties. I'm not really going to talk through it, but you could look at all the properties of parallelograms, rectangles, rhombuses, squares, kites, trapezoids, and isosceles trapezoids, and not only just know the properties, but know like what they do. So knowing what they do is what the next bunch of questions actually get to. So looking at 20, if you know the properties of a rhombus, you should be able to use those properties. So looking at this, 7x plus 3, because it's a rhombus, all four sides are equal, and that's key. So that's going to let me say 7x plus 3 equals 11x minus 21. So there's my setup here. You solve that for x, you get 6. Beyond that, you just basically plug it in. So once I get 6, I plug it in. 6 times 7 plus 3 is 45. So all four sides are 45. So that means BC is 45. Even though I don't have anything to plug it in, I know they're all the same. So it's 45. AM is 12 diagonals. Because it's still a parallelogram, diagonals bisect each other. So AM is going to be the same as MC. BMC, that's a property of a rhombus. The diagonals are not only bisect each other, but they're perpendicular to each other as well. So that's 90. The diagonals also have that last property, which is they bisect the angles. So therefore that's 33. So the other side's 33, and the whole angle is 66. 33 plus 33. 21's a rectangle. So again, rectangles have two properties that are kind of unique. Otherwise, they have just the same properties as parallelogram. So the properties of a parallelogram, opposite sides congruent. 3x plus 15 equals 5x minus 3. Solve, you get x is 9. DC, you plug it in. 9 plugged into here. Pretty simple. BC, plug it in. 9 plugged in there. And the other property, kind of unique to a parallelogram, or not to a parallelogram, to a rectangle, is that these angles are 90. 2y plus 1 is 90. So that's how you're going to find a y. So check your work, see if you got it. Number 22, 23, 24, and 25, still working with properties of quadrilaterals. 22 is a square. Square's got every property in the world. All the sides are the same. So the way I'm going to find x, I'm going to say 3x plus 2 equals 10. Pretty simple. All the diagonals bisect each other. and the diagonals are congruent. The diagonals also are perpendicular, so you got all this stuff. All right, the diagonals also bisect the angles, so we're going to use that in a moment. But if I do that, if I know AM is 5 root 2, I know MC is also 5 root 2, so that's the second thing I had to find. And then I know BD, since it's equal to AC, is going to be 5 root 2 plus 5 root 2, or 10 root 2. So that's what I got going there. Angle ABC, because it's a property of a rectangle, it's got to be a property of a square, because the square's got all the properties, is 90. AMD, also 90. So AMD is this angle at the center. Its diagonals bisect each other and are perpendicular and are congruent. And then lastly, CDM. So this one's 45. So if I look at CDM, I know that that's like this angle in here. So that angle is going to be half of 90 because all the diagonals bisect the angles. Half of 90 is 45. 23. Talking about a trapezoid. Trapezoids don't have that many properties. Really just these two angles are sup and these two angles are sup. That's really all I can do. So the way I find x is I set these two equal to 180. You solve, get x is 10. And then you just plug it in everywhere. And the way you're going to find, the only other angle you can't find straight away is D. D is going to be sup to C. Right? D is not equal to A. A lot of times students are like, these are equal. No. The only thing I know about a regular old trapezoid is that these add up to 180 and these add up to 180. Like if I look at this one right below it, this is not a regular old trapezoid. This is a special trapezoid. This is an isosceles trapezoid. In this case, you do have symmetry, right? You cut that line down the middle. These angles are equal. So are these. Okay. So that said, that's kind of how you're going to find 25. I want to just talk about that real quick. 4x minus 8, because I only knew 62 and 4x minus 8, but I could find that this angle is 118 because these are sup. So this is 118. So 4x minus 8 equals 118. Solve, you get x is 34. Angle D also, sup, it's equal to A, so that's 62, angle T, also 118. That was the first thing I found. All right, backing it up to 24. Kites have line of symmetry we talk about all the time, so kites just cut right down the middle. Everything on either side of that line are equal. So this angle, this side and this side are equal. This side and this side are equal. So that's the main property of a kite. There you're going to put the system. You already have opposites, so these cancel. You get 4x equals 24, x is 6, and then you plug in 6 into either equation to find out y. So if I say 6 plus y equals 8, I know that y makes 2. All right, 26, same kind of thing. You got a kite, you got that line of symmetry. The big property with this one is that the diagonals are perpendicular, which allows me then to say this plus this makes 180. So that's the setup. Solve for x. Once you find x, you could plug it in, BAF and BAD. So, yeah, so this one would be BAF is 27, and then BAD would be, because the diagonals bisect those angles, 27 times 2. So just to show you that, this is 27, so is this. So therefore, BAD is just times that by 2, times 27 by 2, you get 54. Number 27, you got a rectangle. Once again, rectangles have lines of symmetry as well. Rectangles' lines of symmetry are right down the middle, kind of like that. So anything on either side of those is the same. So what that means is right away I'm like, okay, y would be 72. I know that this triangle, right, if I just kind of highlight this triangle, I got two angles that are 72, and then angle Z would be 180 minus 72 minus 72. 72 and 72 together is 144. So that's how I got that. So that's how I found angle Z and angle Y. Angle X, you also know the property of a rectangle that the diagonal, or not the diagonals, the angles in the corners are 90 degrees. So if 72 plus X makes 90, right? I just showed it up here by taking 90 minus 72. But either way, 18. And then lastly, ln. Because this piece is 10, diagonals bisect each other and they're congruent. So you got all these pieces are 10. Therefore, ln is 10 plus 10 or 20. So a lot of symmetry with these shapes, especially kites, rectangles, isosceles trapezoids, rhombuses. Look for that symmetry and it should help you. 28 is a mid-segment property. So the median, mid-segment, whatever you want to call it. But this segment is the average of these two. So basically, if I take 2 times this, it equals this plus this. So that's the setup. So 2 times the mid-segment equals x plus 58. So that's the gist. Solving that equation, you get x is 1. GJ, because this is 9, and these are mid-segments. Mid-segments, or medians, cut through the midpoints of the sides. So in this particular case, they're all 9, and that makes GJ 18. 29, parallelograms. Again, this is one of the first things we learned. But parallelograms have 5 properties. Opposite sides equal. So we'll highlight all the properties I need for this one. Opposite sides equal. right? And then and then the other property is that consecutive angles are supplementary, right? So consecutive angles means angles that are next to each other. So W and 112 would fall into that category. Those are supplementary. They make 180 degrees. That's why W is 68. X should be 16. And then 5y. These are pretty simple equations to solve. All right, next page. Now you got to find areas. There's a bunch of formulas you want to use here. Area of a parallelogram. So we'll write this out. Area of a parallelogram equals base times height. So the base is 15. The height I don't know, but I could find the height by taking the fact that I know this is a 30, 60, 90 triangle, right? And I know that diagonal, the hypotenuse is 12, which makes the short leg 6, which makes this height 6 root 3. So I got a base of 15 and the height 6 root 3. So that's why I showed that right here, but that's when my area is 90 root 3 with the height 6 root 3. For 31, you're using the formula for the area of a regular polygon, which is 1/2 apothem times perimeter. You got to practice this because it didn't give me the apothem. The perimeter is pretty easy to find, right? So that's 60, just five sides, all 12. Finding the apothem, I got to do tan. So in this case, we practice this quite a bit, but I'm doing 36's right here. This is the opposite. This is the adjacent. So the tan of 36 equals 6 over A. A ends up equaling 8.26. So therefore, 8.26 is the apothem, okay? The perimeter is 60, that's pretty simple. And then the area, I just use that formula, 1/2 apothem times perimeter. You should get 247.8. All right, moving on, more area. Area of a kite, wrote it out for you, 1/2 D1, D2. So in this particular case, they gave me, this diagonal was 20, and then I had to do some work to find the other diagonal. So the other diagonal, I got to do Pythagorean theorem to find. So I got, to show you that work, so I got x squared plus 12 squared equals 15 squared, right? So when you do that, x equals 15 squared minus 12 squared, and that gives me, end up solving that equation, you end up with 81. Square root of 81 is 9. So that's 9, and since the diagonals bisect, the one long diagonal bisects the short, I'm going to get 9 and 9, which makes that whole diagonal 18. So I got two diagonals. I got one that's 20 and one that's 18. So 1/2 20 times 18. So I put that together, gives me 180. All right, so trapezoid. I wrote out the formula down here for the area of a trapezoid. These would be great things to put on your note card. All right, so I'm going to do 1/2 20 plus 8 times the height. I don't know the height, but I use Sohcahtoa to find it. Height ends up being 6.13. So now you plug that in, use your formula, you get 85.82. So you can see how I did that. If you see anything, not sure about, pause it. Circumference and area of the circle. So two formulas you got to know. Circumference of a circle, I write it like this for my class. Area of a circle, we write it like this for my class. So we do this. So the circumference is simple, it's just 18 pi. The area, on the other hand, I need to find the radius. So the radius is 9. 9 squared pi is 81 pi. So pretty simple when you look at that one. This one, find the area of the sector and the arc length. Area of the sector formula, we know S equals the measure of the arc over 360 times the area of the circle, and the area of the circle we know is r squared pi, right? So back to, write that out like area of the circle. So the area of the circle is r squared pi. So now I go 24 squared pi. So I'm going to find the area of the sector. So the area of the sector ends up being 216 pi. This is I'm going to find arc length. The key difference here, one key difference, arc length uses circumference of the circle. Area of sector uses area of the circle, right? So realize the difference. It's a really simple difference. But those are the answers you should have got for 35 right there. 36 is a quadratic. It's a real simple setup. This equals this. Solving for x, you get x is 9 or negative 2. All right. Number 37. RP is tangent. These are equal. Also know these are 90. This was on the most recent test. So the way I set this up is I knew that this is a quadrilateral, in which case I know all four sides, all the angles add to 360. So the sum of the interior is 360, right? So you do that, you set up the equation 4x plus 2x plus 90 equals 360, and I ended up with x is 30. So that's how that works. All right, next page. Again, more recent stuff. You kind of see what we did here. You got two diameters in this problem. You got RU as a diameter, and QT are diameters. That's going to be pretty helpful because when you have a diameter, you know that the arcs are 180 degrees. So I also know I got a couple vertical angles. 47 is vertical to angle QPR, which would be also 47, which makes QR 47. All right, and then you know that you got two angles, two arcs that are 180. So then I do that, right? So look at the answers. You can try to figure this out. Yeah, it's, again, most recent stuff. I'm not going to spend too much time because you just learned it. Number 39, same kind of thing, very recent. This whole segment, this AC is 17 because 9 plus 8 is 17. So therefore the radius is 17. So I got 8 squared plus x squared equals 17 squared. You find x is 15. And I want to find BD, which is the whole thing, 30. All right. Moving along, you got the other property, which is that you got inscribed angles are half the arc. So what that told me is that this arc is 140. So my setup is 8x plus 12 minus 12 equals 140. 8x equals 152. X is 19. I want to find also VN. This is a little bit tricky, but I know that this whole arc, VTN, is made up of 140 and 130. So that's 270. Subtract from 360. That gives me what's left is 90. Number 41 are formulas. So you want to review these formulas. I can give them to you really quickly. Sum of the interior is 180 times n minus 2. Again, n equals the number of sides. So if I have 10 sides, sum of the interior would be 180 times 10 minus 2. Each interior, I could take 180 minus each exterior, or I could take the sum of the interior divided by the number of sides. So that's if I have a regular polygon, right? So this is a regular polygon. Sum of the exterior for every polygon is 360, right? And then each exterior, if it's a regular polygon, I could find this, is 360 divided by the number of sides. So real quick rundown of the properties. You probably have these written somewhere in a little bit of a nicer format, but those are some things you probably want on your review note card. All right, 42. I know all these angles we just talked about. Some of the exteriors add up to 360. So these 5 angles add to 360. 4x plus 220 equals 360. X is 35. All right, simple. You solve it. Next one, same kind of thing. I don't add these all up to like 360 or 180. I know that this has 6 sides, so I got to first figure out how much all the angles add up to, and that's the formula we just talked about. 180 times 6 minus 2. 6 sides, n minus 2, you get 720. So there's your setup to solve that. You get 164 for the missing angle. The last one here, 44, it gives you a pentagon, and this is a regular pentagon. So you got all the sides are equal. So one of the 2 equations you need is x plus y equals 30. So therefore, that's an easy one, right? The other equation is a little bit trickier. A lot of you are probably looking at, where did you get 108? Well, we talked about each interior of a regular pentagon. A regular polygon is going to be the sum of the interior divided by n, right? So the sum of the interior of a pentagon, right? So that's going to be 180 times 5 minus 2, which we know is 540. So therefore, I got 540, and the number of sides is 5. So each interior angle we just determined is 540 divided by 5 is 108. Again, if that's too fast, just go back and look at your formulas. You know this, though. So in this case, all the angles add up to 540. They're all the same. They all got to be 108 because it's a regular polygon. So therefore, the setup for my second equation is 6x plus 2y equals 108. So now you got to solve that system. So now you multiply the top equation by negative 2. Give me negative 2x minus 2y equals negative 60. Cancel these out. You get negative 2 plus 6x is 4x. Negative 60 plus 108 is 48. X is 12. Go back to the setup. If x is 12, y's got to be 18. But I showed that other work right here too, so I didn't see that. So hopefully this helps. Pause, rewind if you need to. Thanks.